right, we're going to look at some of the pages that got scaffolded and probably spend some time talking about LINQ as well. I put a number of things on here, and we should make a point to talk about debugging as well. I had last semester, or a couple semesters ago, students asked a question about these things. So there's some resources about dependency injection and database context, exactly what those mean, more details. These are probably, I would categorize them as supplemental information. So, they're not an absolute requirement for you to go over. I would suggest that you go over the LINQ tutorial though, and debugging code in Visual Studio. So I want to start out by showing what I have, and I want to talk about the search functionality and make sure that we talk about that, and that will serve as sort of a introduction to our discussion about LINQ. LINQ, L-I-N-Q. I think it's pronounced LINQ. I don't know. All right, so this is a version of the movie example that we've been looking at for the past several weeks. One thing, by the way, please put on the navigation a link to the things that you have. So if you access movies, if you want me to be able to access movies, put the link in. So I have, it starts with an empty database. One thing, since all the machines, all the lab machines and classroom machines reset every time, unfortunately, it doesn't keep my database. So I have to start with a fresh database each time. So I'll go in and I'll put in a couple of movies. I'll do Star Wars. We've done Star Wars before. What should I put in? I don't know. It's the last movie I saw. Can't I think of any movies? This the release date of, I'm just going to make something up. Genre. I don't know if it's really considered sci-fi, but that's what I'm going to call it. And the price of the DVD is $15. I'll put in another movie, Spider-Man. Released. Also sci-fi. Price of DVD, we'll say $16. And finally, we'll put in Spider-Man 2. Released matter. Sci-fi, and price of DVD, $17. I can't do 17 point. All right, so here's what we have here. And pulls them up. And I've added a search by this where we can search by price. And we can search either less than or equal to or greater than or equal to. So I could put 16 in and say I want everything less than or equal to 16. That should give me Avengers and Spider-Man. It does. I could say give me greater than or equal to 16. It will give me Spider-Man 1 and 2. I put in 1650 and say greater than or equal to, it just gives me Spider-Man. What I'm doing really is I'm testing the code. What happens if you put something in where there's no results? Everything is greater than or equal to 299. Does it blow up? to test for that. Likewise, what if I put something in that is nothing less than or equal to that? That also works. You need to test both these, and I would test the equal part as well. So if you're going to put in, 1550 and say, give me everything that's greater than or equal to that, that's all well and good, but I would also test something greater than or equal to 15 to make sure it catches that one that is equal to 15. And then go a little bit above and make sure it doesn't catch it. So one thing that's been sort of a mantra in my class and in all my classes as of the last several years has been testing. Because don't take this personally, but most software developers don't test thoroughly. And definitely most students don't test thoroughly. All right. Because they may run a test or two and think it's okay and it's right, where really, you need to think through, what do I need to test in this example? All right, there's two conditions here, so I have to test that. It would make sense to test a condition where everything gets picked. Test a condition where nothing gets picked. Test a condition where some get picked and some don't get picked. Test a condition where there's something right on the border between it. I haven't been adding them up in my head, but that's probably 10 different test cases to test this, to be able to thoroughly say, yeah, this works. Okay, so let's look at the code that does this as a jumping off point. So I think we saw before, I think we looked at the index page before. We saw how it worked. Right? That was without a search. And I know for the one homework assignment, you had to add a search in, but you might have been doing that just following the instructions and not understanding it. My aim is to make you, or is to help you understand the code that is needed for a search. So let's start out here. This is our model for the page. Public iList movie. All right. That is the list of movies that's going to be displayed on the search page. If we look at the Razor page, notice that we are looping through from the model a movie list. We have a loop here to loop through and loop through for each item on the list. So that index page, that search page, it's going to contain a list of movies. Now, there's two properties which say support get. What that means is this, and the two properties are search string and search type. We're going to use them down here in our get. What that means is that the values from the form named search type and search string automatically get put in these variables. In other words, when we run this, this text box is called, what I say it's called? It's called search string. And this one's called search type. If we were to look at the HTML that got generated here, we would see that that select somewhere down the lane has a name of search type. And the text box has the name of search string. So those are the names on the form. Because we have said here, supports get, What that means is when we do the get method, the values from the form automatically get populated in this into these things. Now, if you've done other programming, if you've done any PHP programming or even earlier versions of .NET, it saves you writing an instruction to populate it from, or if you've done even JavaScript, for example, this saves you the extra step of having to populate the variable from the value that is on the form, or is on the query string or the form collection. So that's what this does. Without it, if we omitted this, this variable wouldn't know where to get its value from. And it would be unpopulated unless we wrote some instructions to populate it. This automatically makes it happen where it's going to put the value from this text box and this dropdown into these values. Error string is simply an error that we're going to display if there's a problem. All right. So on sync, on get async. Set the error message to 0 or to empty string. So we clear out any error messages that were there before. We try this instruction. We try actually this block of instructions. Try var movies equals m in context movie, select m. What is that doing? We could have written this a number of different ways. Essentially is giving me every movie. This part of it right here is giving me every movie in the list of movies to start out with. To start out with, we're starting out with a list of every movie. We're then going to filter it out based on our search criteria. And we're only filtering it out if that search string is not null or empty. The exclamation point means not. So we're only doing this code if there's a value in the search string. Right? If there's no value in the search string, we skip these statements. And we end up doing this statement, which is getting a list of all the movies that are in the movie table. If there's something in that string, we're going to do some filtering. We're going to do some filtering by adding, where are we going? That where clause. Close the door. I don't know if it's distracting you, but it is to me. So if there is something in the search string, we're going to go and do our filtering. We're looking to see if the search type is equal to LE. So our two choices in that dropdown are it's equal to LE or it's equal to GE. So if it's equal to, less than or equal to, we execute this statement. If the dropdown has greater than or equal to, we do this statement. What we're doing now is we're refining that movies list. Here we start out pulling out all the movies. Here we're saying we're going to take that movie list and transform it by only giving us the movies that meet this criteria. So what this effectively is saying is where that movie where that movie has this following characteristics. S price, so the price of the movie, is less than or equal to the search string. Otherwise, we're going to filter where movie S price is greater than or equal to the search string. So what we're doing essentially is we're forming a list and we're paring down that list. This statement here is going to give us a list of all movies. So if I were to comment this out, and run this, if I were to comment out those if statements and run this, and no matter what I search for, it's going to give us a list of everything. I search less than or equal to, greater than equal, or greater than equal to, whatever. Because this statement says, give me a list of all movies from the movie table. Well, that's it. Give me a list of all the movies from the movie table. But we're going to do something else with that list. And we can do a lot of things with that list. We could, for example, sort that list. All right. Maybe we'll look at an example of that in a few minutes. All right. We're only doing this if there's something in the search string. And if there is an LE in the search type, we're saying take that list, filter it where it's true that these movies, give me the movies where the movie price is less than or equal to the search string. Or give me the movies where the price is greater than or equal to the search string. So now we get to here. There's three paths it could have taken. It could be all the movies. It could be the movies that got filtered this way. It could be the movies that got filtered this way. But in any case, we're going to take a list of those movies and populate our movie list that we're going to use in our Razor page. This lowercase movies here is just sort of like a work list. All right. We're doing our work on that and we're getting a list of movies. We're filtering out. We might sort or whatever. But the bottom line is when we're done, we're going to take that and make our final list of movies, which is the one defined as an attribute of this model. We're going to set it equal to that list of movies. So when we're done, movie has a list. Movie with a capital M has a list of all the movies that we want to see. Now, we may not have filtered it all if there was nothing in the search string. We may have filtered it one way. We may have filtered it another way. I'm going to mess up here. I'm going to change LE to LT. All right. Let's say I forgot that value I'm using for less than or equal to is LE, and I put in LT for I thought it was less than. Now, when I run it, of course, it's not going to work. It'll work for greater than or equal to. But it won't work for less than or equal to. It's supposed to give me things that are less than or equal to 16, and it doesn't work. So how are you going to go solving this? Well, we know what went wrong, so we can solve it right away, right? But usually you don't intentionally make errors in your code. Usually you did something accidentally. So I joke around with my classes sometimes that one way to tell what went wrong is just to stare at the code. until the idea pops into your head. And that's not a good approach. It's best to systematically take that approach. And in Visual Studio, there's an excellent tool called the debugger that we can run, and we can set breakpoints where the execution of the program will stop, and we get to sort of zoom in on the code and trace through the code to see exactly what happens. So I'm going to set a breakpoint here. That means that when it gets to here, it's going to stop. So I run it the first time. The initial load goes here. All right. It's showing me the path that it's taking. It spaced out the error message. Movies equals this list. Is the search string null or empty? Yes, it is. The search string is null because this is the first time that page loaded. All right. Because it's the first time the page loaded, it is null. So we're going to skip all these if statements. And we're just going to get the list of all the movies. And there we go, list of all movies. Now I'm going to test for when I type in less than or equal to. So I'm going to type 16, and I want everything less than or equal to 16. So I click submit again. Okay, there we are. I hit it clears out the error message. It's going to get my list of movies. What movies? All of them, because I'm just saying, give me from that list of movies every movie. That's what this is saying. From the list of movie, every movie. I then look to see if the string is null or empty. Is the string null or empty? No, it isn't. I can put my mouse over it and see that the search string has a value of 16. I can hit F1 again. I get to this if statement. In my head, I'm expecting this to be true, right? Because I'm thinking incorrectly that LT means less than. But I can put my mouse over that and see that the search type actually equals LE. And you can look in this menu or in this window and see this as well. The search string and the search type equals 16 and LE. And then when I go into it, I notice that it doesn't hit this statement like I suspect it will, or like I hope it will. It hits this statement instead. And we can continue. And it shows us the wrong movies. If you're running code and it's not working the way that you expect it to, I definitely expect you to run it through debugger first. That doesn't mean that I expect you to understand everything that happens or that you that you can figure out every problem just by running debugger, but I want you to try it and follow through and see if the code is running the way that you expect it to. All right? Because a lot of times when you have in your head that something works a certain way, it's hard for you to see when it doesn't work that way, when it works a different way. All right? Okay. So we studied a where clause on how we can filter data in here. Essentially what this says is make the new movie list, movie with a lowercase m, that's our working list. Take our current list And filter, S represents each movie where the price is less than or equal to, or the price is greater than or equal to. Now, notice that there's exception trapping here. The exception trapping is, what if I put in what if I put a non-numeric item in here? Ooh, it blows up. Interesting. Well, that's something we'd have to take care of now, wouldn't we? I'll take care of it in I will. Yeah, I'll try to fix this during class. If I don't fix it during class, I will fix it and post the answer. All right, let's just behave ourselves and do everything correct. If I put in 13, there's nothing less than or equal to that. If I do greater than or equal to, all right, that comes up. Now, the point of this is that once we exit this onGetAsync, in the variable movies, in the variable movie rather, is a list of the movies that we want to see, a list of movie objects that we want to see. What's a movie object? Well, we define that in our model. It's one of these things that has an ID, has a title, has a release date, has a price, and so on. Now, let's look at the Razor page itself. It's using that model so that the code in that model runs first, creates this list. We're now going to go on the Razor page itself, create the form. Because we define that this is supports get, this value will store the previous value. If you notice, if I type in a value here, 14 and greater than or equal to, when I click submit, it doesn't clear out that field. Again, that's because of it is get enabled. Or that it supports get, rather. Okay, so I'm displaying the form. I'm going to display any error message that my model produces. I'm then going to create a table. And everywhere you see this @ sign is where it's going to the model to get something. So this is getting for display name of, it's getting the display name of the field in the movie sub-0 of title. Now, all the movies have the same display name for the title. It's the word title. It's not the actual title. It's the title of the field. Just like the display name for release date is not the date. It is the words release date and genre, price, director, and so on. So what this does is this pops into the table wherever we see the @ sign, the display name for, from the model, from the model's movie list, the title of the 0th element in the array. that prepares this header of our table. Here we loop through each item in our movie model, and for each item we display the item's title. So there's going to be as many items in model movie as there are movies that we're displaying. So we're leaping through, and we're going to display the title, release date, genre, price, and director of that movie. All right, let's look at the LINQ tutorial because there's a few things I want to go over in that. This is an example of LINQ, by the way. LINQ stands for Language Integrated Queries. I won't bore you with how it worked in the old days, but in the old days, if you put a wrong database column in a statement, you wouldn't know until you actually went and ran it. That's not good, all right? Runtime errors are far worse than compile errors. Compile errors are good because you know there's something wrong. You have to hunt down and find out what's wrong and correct it. Runtime errors may only appear under certain circumstances, and you might not be able to isolate the circumstances under which they appear. Runtime errors are unpredictable. They may not give you an error every time, but they may give you an error under certain circumstances. So because of that, the fact that this is integrated into the language means that we're going to get actually compile errors for things such as invalid column name and so on. So LINQ, Language Integrated Query, allows us to process lists. LINQ allows us to do things with in-memory objects, data sets, stuff from the entity framework, that's us, XML documents, any other place. There's actually two ways to write LINQ queries. One is called the syntax approach, the query syntax approach, and the other is called the method approach. Notice that we did from movie in context, select M. So we did the LINQ query syntax for part of this. We did the LINQ method syntax for another part. So if we're looking at this part of it is the query syntax. This part of this is the method syntax. And there's equivalencies, there's resources that tell you how to convert one to the other and so on. I generally prefer the method syntax. And they go through examples. They're doing it with lists of integers. We're doing it with lists of objects. That's the big difference in our case. the LINQ order by. That's what I wanted to add. Let's look up what the method syntax says for order by. This is the query syntax. Method syntax is the dot order by method. So, going back to our example, let's say I want to display it in order of price. So I'm going to take my list and I'm going to do something with the list. I'm going to take what the list was before and say I want to use the order by method. What do I want to do with it? I want to order by price. So I'm going to order by each movie. Each movie I want to be ordered by movie dot price. It's the key thing of what I was saying a minute ago. Notice when I type in PR, price appears. Why does it appear? Because it knows that this is a list of movies. The language understands and knows that. So I'm able to go and do a query or do anything based on that. So now when I run this, if I pick $14, gives it to me. Unfortunately, I entered these in price order, so it's hard to tell that it is sorting it. Let's go in and do descending so that we can see. Well, actually, we'll do descending if they do greater than, and we'll do ascending if it is less than. By descending. By descending. So let's do this. If I pick movies and I pick the lowest one first, if I pick less than or equal to, I will order it by price ascending. That's the default. And if I pick greater than or equal to, IntelliSense wasn't coming up to have me work. Okay, so now when we go and run it, should give us our desired results. And it looks like this is locked up. And task, and I hope when I go back in, pick up where I left off. So if I pick less than or equal to, gives me an ascending order. If I pick greater than or equal to, it gives me the opposite order, the reverse order. So descending order. We're going to be doing a lot of this, and it's important to understand how this works. Taking and altering LINQ queries. What I would like you to do over the next few days is look at these other examples code. Create. How does the create work? So that's pretty simple. Look at the delete. How does the delete work? That one is sort of simple. Otherwise there's some small extra piece of code for unusual circumstances. Look at the edit, look at the details. I may or may not have time to go over those in class, so please review those on your own and bring any questions that you do have to class. Are there any questions now? All right, that's all I had for today. We'll see you either in lab or next week.